The following section is brought by Ivan Ma from Hong Kong MySQL User Group. Ivan has spoken in our Hong Kong Open Source Conference many years, and thank you to his support to us. Ivan has over 20 plus years with IT technology around databases, infrastructure, and project development. He is leading the Hong Kong MySQL User Group. His career started as developer from IBM TSO, S36, AS400, COBOL, RPG, and as consultant principal solution architect in Sybase for over 10 years. He joined Oracle from the Sun Microsystems and now he is working in MySQL Team as principal solution engineer. His topic today is sneak preview on MySQL Operator for Kubernetes. May I pass the time to Ivan, please?
Good afternoon. This is about sneak preview on MySQL Operator for Kubernetes sections. My name is Ivan Mark. I'm from Oracle based in Hong Kong. So I hope you enjoy today with the demo and how we show you the operations using the MySQL operators to create InnoDB Cluster on the Kubernetes platform. So everybody is looking for the high availability for the database service. And for here today, we use InnoDB Cluster, and someone may create it through the compute nodes on just VM. And there's also today using the operator is more handy and easy way to set up, manage, and it does all these automated failover is managed automatically. And there's also another options on cloud, and particularly on Oracle Cloud, we have the MySQL database service. It is easiest way to set up, manage, and it does automatically failover, and it is managed as service on cloud platform. So what is Kubernetes? It's the platform to orchestrate the service, and it is open source, extensible, and with all this like container workload. And the operator is to facilitate and deploy the service. And today it is about MySQL service. And the goals of this operator is about deployment, configuration, self-filling, how to do backup or serve, and defining this custom resource definitions. So what is the InnoDB Cluster? InnoDB Cluster is the HA #1 platform, which out of the box from MySQL deployment. And you see in the diagram, we set up the web replication with single primary, MySQL 0, MySQL 1, MySQL 2. So 3-node cluster, and there are 3 routers. And the applications connects to, for example, load balancers from Kubernetes and connects to one of the router, and that directs traffic to this MySQL servers. And there's also MySQL monitor if you need it to give you chart and graph. So let's see what is MySQL Operator. So basically, it is now today public privilege. Okay, you can access through the GitHub. The website will show you later on. So generally, we try to do this automate the MySQL deployment, and the server router it does self-healing back and restore, and as well as how to do scale up and down for number of instances about router and server. And people may also choose to use community editions for the image, or they can choose enterprise editions. As MySQL is actually owned by Oracle, it is fully supported by Oracle, and this is about this MySQL operator. So with the HA capability and number of nodes, and we do rolling upgrade when there is new versions coming out. So to minimize and reduce the downtimes that are possibly introduced during the upgrade. And together all this like configuration management and copy the data through the clone plugin, as well as you can create your private container registries to host your image. So here it is. The operator basically create the router as the replica set, which can be number of instance. In here, it's talking about port 0 to port N. And the InnoDB cluster and has number of nodes, which it is the 3 nodes, for example, can be 5, can be 7, or maximum as 9. So The MySQL server is created as the stateful set. Okay, stateful set, port 0, port 1, and port 2. So the port basically has two containers. One is the agents called sidecar, and the other is MySQL actually is attaching to the PVC, the persistent volume claim, and attached to the physical, the persistent volumes to the storage. So the container image, you can get it from the Docker Hub, which is the community editions, or actually the commercial edition from container-registry.oracle.com. So we retrieve the server and router from the image registry. So there are quite a number of very popular Kubernetes platforms. So people may use Venture or some other things, or Minikube, which is the very small VM. And with today, I try to use the Oracle Cloud Platform. We call this OKE, Oracle Container Engine for Kubernetes. And it is easy to use, and it's just on the platform and the cloud, just click, 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 and then we have the Kubernetes environments. So as a cloud native service, the OCI offer all this like platform, and for developers, for the deployment, and even serverless interactions. You can create functions, and through the API gateway, translate all this API and into your application into a database. So here, this is the demo how to create the Kubernetes. First, on the cloud, once you log in, you have the main page, and we can actually do this by search for the Kubernetes on the menu. So that brings us to the OKE. So when we open the OKE console, we can create a cluster by click the quick create. So give it a name and where the compartment is, and the versions and API endpoint, which we define as a public, and the workload, which is internal. And there's actually the compute shape. And today we try to use minimal 3 nodes. Each node has 16 gig. And all this once this is done, and it will actually create the node pool. And 3 node will be actually installing the Kubernetes workloads. So just wait a bit, and we just close this creation process. So it brings back to the console. So the console is telling this is still in creating stage, and the node pool is being created. So it's the node pool right here. We see there are 3 worker nodes being created. So the worker nodes 3. Okay. So once we have this, and let's see how we do this access. So at this point, you can see the beta versions. You can find it in the github.com MySQL-operator. So we can create a custom resource definition so that we have the InnoDB cluster backup policy and some other actually the definitions. So we can apply this YAML file. So the CLD YAML file, as well as to deploy the pod, which is called MySQL Operator. And once we have all this, the namespace is created as under MySQL Operator, and we can get the pod, and which is supposed to be running after this. So let's see how to get access to it. So we have the Kubernetes up and running. So let's see how we do this. By clicking onto this detail page, and we can get access to the access cluster, and we open the Cloud Shell, or you have your own VM. So with the access cloud cluster, this actually brings you the box. And this pop-ups to tell you how you can create the configurations. So we just copy and paste it back to like Cloud Shell right here. So once we have this and execute it, so we can use kube control, and this will direct connect to the cluster from the product endpoint. So now we have already getting this 3 node up and running. So it is actually 3 nodes up and running. So what next is we try to bring this Kubernetes MySQL operator onto this OKE. So we can actually switch to the GitHub. So if you look at the web page, you can find the 2 particular command line. We copy and paste it back to the command lines right here is the shell. And we create a custom resource definitions the first, and the second is to create the operator. So we just paste the operator link right here. So what we do actually, we have the operator up and running. So we just try to get the operator. Okay, the port and the namespace being defined as the MySQL-operator. So it's being created and getting the container. So once we have actually do this, the CLD is being created. Okay, the CLD and the operator is up and running as active. So we have the operator, and what next is we create the MySQL server, right? The MySQL service, which is the InnoDB Cluster as 3 nodes. So before that, we have to define the root password. So we create a secret. So the secret named as the mypwds, and we can create and apply this YAML file, mycluster.yaml on the right-hand side, which is my cluster as the meta name. And the kind is InnoDB Cluster. It is the new defined words, right, from the CLD. And the secret name is being defined as in the first point, mypwds, and the number of the instances it is defined as 3, and router it is 2. So we'll be creating this under particular namespace. Let's look at this demo. So it is live. So we will try to actually create this secret. So the first secret is to get the GitHub. Okay, why we need this to get the image? Because sometimes when it use the anomalous users, so many people using the same platform, it will exceed the daily limit. I forget there is maybe 200, 400. So no matter what Oracle, we have so many people using it. Yeah, many times we'll hit the limit. So that's why I have to use my own secret and to connect to the Docker Hub. So you can use your weight as well. Otherwise, you just skip this. So once I have this, and then what next? I have to create the username, which is my root, and my root password. So what this YAML files, IC01 YAML, is to create a secret mypwds as a secret name. So we try to use control, apply this YAML file, and this is on the namespace called Hong Kong OS, open source. So we just create a secret. Then what next is to create the InnoDB cluster. So the InnoDB cluster is on the another file, the IC02 YAML. So you can see the name, the cluster name is my cluster, and the secret name is mypwds defined earlier, and the base server ID is 2000 and starting from there. And the Docker secrets, as mentioned earlier, and number of instances for router is 3, number of instances for the server is 3, and it has extra information to define as the my.cnf to append some other information like time zone, okay, which tries to alter this like Hong Kong time zone, GMT +8. So as well as to open the general logs, which production should not be used. Anyway, so I define the storage size as request the 5 gig. So now we apply this YAML, it is up and running, but it is still creating the container. So you see, first of all, the cluster has number of ports. The 3 port which it will be created, the my cluster-0, my cluster-1, my cluster-2, and as well as the router, MySQL router dash some other magic words. So after a while, we'll be seeing 3 nodes running. So there are a couple of servers being created. The InnoDB cluster as the keywords, right? And when we look at it, okay, the online is at this time is still 0 because it's still creating the server. And number of instances S3, router S3. So you can see this, they are the InnoDB cluster is created as stable service and my cluster, whereas the router is created as replica set. Okay, so the difference stable set and replica set. As like stable set, it controls the sequence of who is up first, right? So, but the replica set is quite independent. It's like stateless. So once we have all this, we can get also we have all the service and including the my cluster, which is the router IP router port number 6446 or the read-only endpoint 6447. So it is now being created. The InnoDB cluster is still in progress, and right after this, we have the my cluster 1, 2 as well. And as well as the bring in the InnoDB cluster is all online. So we can access to the shell, I mean it's the Bourne shell, and to a particular container. So as mentioned earlier, there is a MySQL container as well as the sidecar container. So the port has two containers. One is as the agent to manage the container which run in the database. So now I connect to the MySQL, okay, servers to the first node. So you can see, yes, just right there. So at the end, I will try to export, okay, the port. So you can see what I do here is to create, to expose the replica set router port 6446, okay, target port 6446. And it is still up and running. Okay, we just have to wait this load balancer as type load balancer to come up. Okay, we need the external IP. So by having the external IP right here, 129.159.109.149. So having this, that means we will be using this IP address to access even from external. Okay, from externals to get access to this. So just to remember, on the cloud, you might have to open the privilege to access to it. So my cluster 0, so we can actually use this external IP and access to it. So after this, you can see we have new keywords, InnoDB cluster. You can get InnoDB cluster and watch it and get any changes to the status. And we have the service, my cluster points to the router 6446. And as well as the PVC, the persistent volume claim that will try to claim on each of the nodes. Okay, so there is also to expose the load balancer, which I did it, or you might want to just perform on your particular VM. So here's just to scale, how to scale, like creating the cluster with 5 nodes, okay, instead of just 3. So we can actually just add the InnoDB cluster and putting it the name and from 3 to 5 and just scale. Okay, it's automatically scaling load time and it manually update the stateful set and definitions, and that will be reflected on the InnoDB cluster. And if there is new version, we do rolling upgrade and one by one. That's actually the beauty and also the goal to have the MySQL operator. So here, this is the demo, how to do scaling as well as creating an application which we call the PHP admin. So let's look at this. So first of all, this is to show you try how to scale. So we use control and checking the InnoDB cluster, and there's also short form IC or ICS. The InnoDB cluster actually it is running with the 3 online and 3 instances. So what I do is to edit the IC, my cluster, and tries to find the number of instances as 3 to change it to 5. So I search for the instance from this edit. And it's going after just the added instance, and we'll be able to see the 3 and change it to 5. So once we have done this and save it and then exit, so what we'll be giving in this is to have the IC up and instance as 5, but the online is still being created. So if I search for and look up the ports, running in the namespace Hong Kong OS, and you'll be able to see it is being created, right? So now show 1, 2, 3. So it is being created as the 4th node and 5th node. So on this, you can see the 5th node 1, 2, 3, 4, up and running. We can access to it. We can switch. We can use MySQL shell and then go after this. So you can see they are the 3 nodes. We can use this MySQL shell and switch the primary nodes from the first MyCluster. And now we change it to the MyCluster 1 from MyCluster 0. So the active node, actually the read-write node is changed now. So if I try to run this again, so you'll be able to see this. Okay, so connects to the router will point to the new read-write primary, which is the MyCluster 1. Right. So now we do scale, we do switching, and as well as now we try to deploy the PHP admin. So the PHP admin, we have the YAML file PHP admin. We try to apply the PHP admin dot YAML. The YAML is being created, right? So the service is up and run sooner or later. Now it's done. So the PHP admin is run. So what we need to do next is to create the external accessible IP. So we do load balancer, is to expose the IP. So we apply the PHP admin load balancer YAML. So once we have done that, and we have to wait for the IP provisions. So the IP is being created. So let's wait. So getting the service, one is the PHP admin service, and the external IP is still pending. It is still pending. So just wait a bit, and we'll be seeing the IPs coming up. So sooner or later, we'll be getting the IP. So this is how easy we can deploy and expose the external accessible IPs to access to the portal. So we will be using the PHP admin. So the YAML file actually defines the cluster access, so my cluster as well as the 6446. So the IP will be coming up. Yes. So that's the IP 129.159.91.53. So let's open a browser and pointing to the IP, and we'll be seeing the PHP admin up and running. So we log in as the myroot and getting in. So this is checking about the cluster, the InnoDB cluster created by the MySQL operator. Okay, so to give you a summary, the MySQL operator gives us the self-healing and auto failover and all these things, and switching primary, do it easy to scale up and down. And to destroy everything, just delete InnoDB cluster, my cluster, or for my demo using the namespace, just delete the Hong Kong OS. So in conclusion, you can see the MySQL operator for Kubernetes is designed to help operate the Kubernetes, quite handy. They simplify all these operations and allow the HA capability and within the Kubernetes environments, and offers the native experience, Kubernetes experience to the users. Currently, it is in beta. So stay tuned for the official GA release and check on the website, github.com MySQL-operator. Thanks a lot. Have a good day. This is the end of my section.